Hey squad, today we are going to be doing a little bit more with volume, but something a little more challenging than what we were doing in the yesterday. Yesterday we were just doing length times width times height. Today we're doing that, but more than once. So what do I mean? We're going to be finding the volume of a composite figure. Okay, this right here, this big picture on the top right is a composite figure. Okay, so what that means is essentially we have more than one rectangular prism that we are going to be finding the volume of. So we are going to find the volume of this rectangular prism, and we're going to find the volume of this rectangular prism, and we're going to be combining those volumes to find the volume of the total figure, which is called a composite figure. So if you look down here, they separated them into two separate rectangular prisms, and then we're just finding length times width times height. So we have length times width times height here. 4 times 3 is 12 times 6 is 72. All right, and then over here, we could do it multiple different ways. We could do 5 times 5 is 25. And then when you do 25 times 11, that's 275. And then we would add them together, this plus this. Oops, should be an equal sign. All right, and then we do 275 plus 72. All right, that gives me a 7, a 4, carry the 1, a 3, so it would be 347 meters cubed. Again, meters cubed because this is a three-dimensional figure, so that's why we have the 3 there for cubed. All right, when we're talking about volume, we're always cubing our units. All right, so when we see this example here, this is a great example to use for finding the volume. So then when we go over and look at a different example, let's go to looking for a specific example. Here we go. This page here. Okay, we are going to be finding the volume of several different figures here. All right, so give me 1 second. So we need to find the volume of this figure up here. All right, so this figure here has a length here, a height here, but doesn't have the width. One of the biggest things we have to understand when we're doing these problems is, okay, so one of the things I was talking about was we need to understand that this line here is equal to this line here because these are rectangles, right? So all the sides of a rectangular prism are equal. So this side is going to be equal to this side. When we look at this face of this rectangular prism, these should also be equal, this and this, because it is a rectangle. So if I look at all these rectangles, everything that is directly across from one another is going to be equal to one another. All right, so all these dark lines that I've just created, and even under here and under here, they're all across from each other, so they're all equal, which means these are all going to be equal to 6. All right, so now I have my length, my width, and my height for this prism, and I have my length, my width, and my height for the bottom prism. So I would have 6 times 3 is 18, times 5 would be 90, and I usually set that up by saying, okay, I have a length of 6 meters, I have a width of 3 meters, and then I have a height of 5 meters. All right, and then over here, I have a length of 8 meters, I have a width of 6 meters, and then I have a height of 5 meters. So then I just need to multiply them all together. 6 times 3 is 18, so then I would do 18 times 5, which would be 90. So this is 90 meters cubed or cubic meters. And then this one I would do 6 times 5 is 30. And then multiply that by 8 just because that's easier for me. Remember, you can multiply them in any order. So 30 times 8 would be 240. All right, so then we would add 240 cubic meters plus 90 meters cubed or cubic meters. All right, and that will give me, oops, I'm running out of space down here. That would give me my answer, which would be 0. 9 plus 4 is 13. Oops, I'm losing my tools here. 13, carry my 1. 2 plus 1 is 3, so it would be 330 cubic meters. All right. Now for this problem over here, I'll draw a little line to separate them. So for number 3 here, we have 3 different figures here. So we have length, width, and height for all 3. Length, width, height, length, width, height, because we're going to have to find the volume for all 3 of these, okay? So we've got a length here of 3 and a width here of 4. We just have to find this height, all right? And we don't have the height here. We look across from it. These are the same length. These are the same length. These are the same length. So we have the height of 2. So we're going to say a length of 3, a width of 4, and a height of 2. Which is the same for this shape because this is the same. So length of 3, a width of 4, and a height of 2. If I multiply them all together, that would give me 24 cubic centimeters. Okay? So both of these are going to be 24 cubic centimeters. Now the top one, we have, again, a length of 12. All right, centimeters. We have a width that we're missing here. This is my width. I don't know that. Look across. Don't know that one. Look across. Don't know that one. Look across again. That's a 4. So that's a 4. And then my height is 2. So when I multiply those together, I'm going to get 96 cubic centimeters. All right. So now I need to take my 3 volumes here, which is 96, 24, 24, and I need to add them. So I can do 96, 24, and 24, and add them up. That gives me 14, and then that gives me 14 as well. So I get 144 cubic centimeters, okay? This is something new, guys. The hardest part you're going to have trouble with is sometimes when you have these missing values, remembering to look straight across to figure out what those values are going to be, okay? Because remember, the opposite sides of rectangles are congruent, all right? I'm here for you all day. We're doing this for 3 days, guys, okay? So if you have trouble on the first day, watch my video, watch the other videos that I'm posting, watch the things that are in the assignments, read the things that are in the assignments, and reach out to me, okay? Good luck, guys. I will talk to you soon. Thanks.